how do you define waves? What are waves? So we say waves are oscillations or disturbances that transfer energy from one point to another. And we classify the waves into two categories, a transverse wave and a longitudinal wave. So look at this figure here. Here you can see the transverse wave, the particles, like if the wave is moving in this direction, the particles are moving up and down. That is, they are moving perpendicular to the direction of the waves. So in the transverse wave, the oscillations or the disturbances move perpendicular to the direction of the waves. Whereas if you see the longitudinal waves, there the particles or the oscillations are moving parallel to the direction of waves. So examples of the transverse wave is light waves and the seismic S wave. And for the longitudinal wave, it is sound waves and the seismic P waves. If you look at the transverse waves, you will see it has some elevations and depressions, which are known as crest and trough. And if you see the longitudinal waves, they have the regions where the waves are closer together, which are the regions for compression. And where the waves are separated, these are the regions for ray refractions. Okay, so now let us look at the differences between transverse and the longitudinal wave in detail. Now, transverse wave, the first basic difference is the definition, which is on the basis of the vibrations or the particles, like in which direction they move. So in the transverse wave, the particles vibrate perpendicular to the direction of the wave. And in longitudinal waves, the particles travel parallel to the direction of the wave. As per the medium, transverse wave do not require a medium to travel, but longitudinal wave require a medium to travel. The transverse wave travel with the speed of light, 3 times 10 power 8 meters per second, where longitudinal waves, they travel slowly like sound waves. Like sound waves has the speed of 330 meters per second. If you look at the characteristics of the wave, the transverse wave has crest and trough. So this top point is crest, the bottom point is trough. Whereas in a longitudinal wave, the wave consists of compressions and rarefactions. The transverse waves can be polarized, whereas a longitudinal wave cannot be polarized. You need to know the examples. Light waves and the seismic S waves are the transverse wave, and sound waves and seismic P waves are the longitudinal waves. Now, this slide is very, very important. They often ask in the exam the examples, the difference, the definitions of transverse and longitudinal wave. So make sure you remember this table. All right. Okay, now let's move on to some of the key terms that you should know for the wave. Now, if you look at this diagram here, this is a transverse wave, and you can easily see this top point is a crest and the bottom point is a trough. Okay, so crest, it is the height of the wave, and trough is the depth of the wave. So this is the trough and this is the crest. Now, this is the mean position of the wave. Now, the distance from the mean position to the highest point in the wave, or the maximum displacement of the wave from the mean position, is known as amplitude. And if we look at this wave, the amplitude is 5 meters. So you should know amplitude is the maximum displacement of the wave from the mean position. Crest is the height of the wave, trough is the depression of the wave. Now, when you have the distance between a 2 consecutive crest, or the distance between the 2 consecutive trough, is the wavelength. So wavelength is the distance between 2 consecutive crests or troughs. So in this case, from here to here, we have a wavelength. Now, what is time period? From here to here, that is 1 crest and 1 trough, is 1 wave. Now, this wave is taking 4 seconds to complete, so that is the time period. And frequency is the number of waves per second. So if you do 1 over the time period, you get the frequency. So frequency is 0.25 hertz. And how do you work out the wave speed? Wave speed is the speed traveled by a wave, and you should know the formula for the wave speed. The wave speed is frequency times the wavelength. And if in case they don't give you the frequency and give you the time period, then you can do 1 over the time period to work out the frequency, and then you can put up in the wave formula that wave speed is frequency times wavelength. Now be careful with the units. The frequency has to be in hertz, time has to be in seconds, wavelength has to be in meters. Okay, this is a very important formula. Make sure you know how to use it. Okay, now let's look at some example question. The speed of the wave is given to you as 330 meters per second. You need to calculate the wavelength if the frequency is 25 hertz. So you have to calculate the wavelength where the frequency is given. So you can pause the video, try this question. And the second, how long it will take for this light to travel a distance of 50 meters. So they have given you the distance and they have asked you to work out the time. Okay, so you can pause this video and have a go at this question. Now see, if we rearrange this formula, the wavelength is given by wave speed over the frequency. The wave speed is 330. The frequency is 25. So our wavelength is 13.2 meters. All right. Now, we know that frequency is speed over a wavelength. Right? Now, the distance is given to us as 50 meters. And for light, we know that speed is 3 times 10 to the power 8. So when we put this into the calculator, we get the frequency to be 6 times 10 power 7 hertz. And you know frequency is 1 over the time period. So time period will be 1 over the frequency. So when we do 1 over 6 times 10 power 7, we will get the answer 1.6 times 10 to the power minus 6. Okay, so I hope this formula and how to work out the wave speed and the wavelength is clear to you. Now let's move on to the reflection. What is reflection? Now, reflection of light is the phenomenon of bouncing of the wave when it hits a medium. So let's suppose this is a mirror and this is the ray that is incident onto a surface of the plane mirror. So that's the incident ray. Incident ray is the ray incident on the surface. As soon as it hits the surface, it bounces back at the same angle with which it came. So this is a reflected ray. It is a ray which is reflected from the surface. Now we draw something with the dotted line called the normal. What is normal? Normal is a line perpendicular to the surface where reflection takes place. So this is normal. This is perpendicular to the surface. And you can see angle of incidence and an angle of reflection. Now, angle of incidence is the angle between the incident ray and the normal. And reflected ray is the angle between the reflected ray and the normal. And as for law of reflection, angle of incidence and angle of reflection are equal. And the incident ray, reflected ray, and normal are in the same plane. Okay, so you should understand this diagram and what are these terms like incident ray, reflected ray, angle of incidence, and so on. Now you should also know how do you make the image of a plane mirror. So this is a plane mirror, and let's say this F is an object which is at a distance D. Now what will happen, this F will send, the light will come through F and then it will be reflected. So at the various places, the light will be reflected and reach your eye. Now I can only see in the straight line. So we will extrapolate these lines backwards and where they meet will be the image, right? So if this is F, the image will be made at P dash, which will be laterally inverted. It will be a virtual image, laterally inverted, upright, and it is the same distance from the mirror. Okay, so image of a plane mirror is a virtual image. What is a virtual image? It is an image that cannot be obtained on a screen. In a virtual image, the rays do not meet, but they happen to meet where the image is formed. So actually, the rays are not meeting here. We have extrapolated it so that it appears to meet there, and there you see the image. Whereas a real image can be obtained on a screen, the rays actually meet, like images of the camera, and the virtual image is image of the plane mirror. Okay, so I hope this concept of reflection and how you draw the image of a plane mirror is clear to you. Now, reflection can be of two types, specular and diffuse. Now, if the reflection is onto a smooth surface, the refracted rays are just parallel beams. That is known as a specular reflection. On the other hand, reflections on a rough surface, where the reflected ray are a bunch of diverging rays, are like diffuse surface. Okay, so I hope this concept of specular and diffuse is clear to you. Now let's come to the phenomenon of refraction. Now let's take an example. Have you seen if you put a pencil in water, it appears to be broken? Why is that? Because when the light is entering the water from air, the medium is changing and the light is changing the direction. As it is changing the direction, it appears to bend slightly in water. Therefore, this part appears little bended and it appears to be a broken. Now, what is refraction? Refraction is the bending of light as it travels from one medium to another. And why there is a bending of light in different medium? Because the speed of light is different in different medium. Right? Now, if the light is going from a rarer, like air, which is a lighter medium, and going into a denser medium like glass or water, then the speed will slow down and it will bend towards the normal. So in this case, if you see in the diagram, the incident ray is going into from air to the water. As it is entering the water, it is bending towards the normal. In this case, the reflection angle will become smaller. The refracted angle will become smaller. So angle of refraction is less than the angle of incidence. But on the other hand, if the ray is traveling from a denser to a rarer medium, as soon as it goes to a rarer medium, it will bend away from the normal. In this case, the angle of refraction will be greater than the angle of incidence. Now, these are the two mediums, air and water. We draw the normal. The incident ray comes to the surface. As soon as go it to the water, it bends towards the normal. And the angle of incidence and angle of refraction is smaller than the angle of incidence. Okay, so this is what is bending of light. Now, what is visible light? Visible light is a spectrum of 7 colors, and those 7 colors are violet, indigo, blue, green, yellow, orange, red, which is very pure. And you need to remember that from red to violet, the frequency is increasing, but the wavelength is decreasing. So red light has the highest wavelength, the violet light has the lowest wavelength. Each color has its own frequency and wavelength. The visible color of the object will be the color that is reflected by the object. So for example, if you see something green, it means that object is reflecting the green color. That is why you are seeing a green color. Now, depending on whether a light can pass through an object or not, we have 3 categories. We have opaque objects, translucent object, and the transparent object. So you can see here, this looks like an opaque. This looks like a little translucent object. So opaque object does not allow the light to be transmitted but absorbs all the light. For example, a book. If you keep a book in front of you, you cannot see what is behind the book. Translucent objects are like plastic. These objects allow some part of the light to be transmitted. So behind the plastic, you see some hazel things. Whereas a transparent object, they allow the light to be transported through them without any absorption. And you can easily see the things behind the object. For example, glass. Okay, so I hope the light waves is clear to you. Now let's move on to the sound waves. As we discussed in the first slide, the sound waves are longitudinal. The sound does not travel through a medium. It does not travel through a medium. It requires a medium to travel. Sound waves is characterized by compression and rarefaction. In sound waves, the particles vibrate parallel to the direction of the wave. Now, if you see this is a low amplitude. This is a high amplitude. This one, the waves are very less. So this is a low frequency wave, and this is a high frequency wave. And the speed of the sound wave is 330 meters per second. Right? Now, sound waves can have any frequency, but there is a human hearing range, which is from 20,000 to 20 hertz to 20,000 hertz. That's the human hearing range. Now, any sound wave which is less than 20 hertz is known as infrasound, and the sound waves which is greater than 20,000 hertz is an ultrasound, and we cannot hear the ultrasounds. But ultrasounds are very important. They are used in echo sounding. They're used to determine the depth of any object. We send the sound waves. They are bounced back. We notice how much time they have taken, and we know what is the velocity. Like by what was the speed of the sound wave. And we can work out the distance by doing v times t over 2. Okay, because distance is speed into time. And since the distance is double, so we divide by 2 so that we can work out at what distance the echo is coming from. Okay, now ultrasound is very important. ultrasound is the frequency of the sound greater than 20,000 hertz. And ultrasound's advantages are they're non-ionizing and harmless. They're partially reflected at the boundary between different tissues, so they can even scan the soft tissues. So ultrasound is used in prenatal screening. It is used to determine the depth of the sea or the obstacle inside the water. They're used to do industrial imaging, and they're also used to detect flaws in medical castings. Now, you should know the advantages and uses of ultrasound. They have come up in the exams, like note-making questions or some short questions, and like what are the advantages, why ultrasound are used in prenatal, because they're non-ionizing and harmless. So you should know all these points. So what are the use of ultrasound? The use of ultrasound is in the ultrasound scanner. Now, what happens in the ultrasound scanner? There's a transducer, and that transducer sends ultrasound waves. It crosses the body and it's reflected from the tissue. The transducer detects the wave reflected from the tissue and image is displayed on the screen in the form of scan. Now, what is sonar? Ultrasound waves are used to measure the depth of the sea or to find the obstacle underwater. In sonar, ultrasound is sent to determine the depth or find any object. The time taken by the sound to come back is noted for the known speed of the sound, and you can do velocity times time to work out what is the distance of the obstacle, and you have to divide by 2 because it is a echo. So it's going and coming back, so it is traveling double the distance. Okay, so I hope this is clear to you. Now, what you need to do next is we need to do the structure of the Earth. Now, we know that Earth has a core, and then the mantle, and then it has the crust. The core, when we talk about the core, the inner core, it is the inner core, and then it is the outer core. Then we have the mantle, then we have the crust. Okay, so when you see the inner core is solid, the outer core is liquid. The mantle behaves like solid, can flow very slowly, and the crust is completely solid. So the crust and the upper mantle cracks and forms a tectonic plate, and these tectonic plate causes the earthquake. Now we have something called the seismic wave. Okay, now what is seismic wave? The seismic waves are the shock waves which originate when the force inside the earth moves the rocks of the tectonic plates. The wave travels through the earth and also across the surface. Now, earthquake takes place when the rocks or the tectonic plate in the earth crust or the upper mantle moves due to the forces inside the earth. The seismology is the study of seismic wave. The nearest point on the surface of the focus is the epicenter, and the device which is used to detect the earthquake is the seismometer. Now, if you look at the seismic waves, there are 2 types of waves, the P wave and the S wave. Now, you can see the red ones are the S waves, and you can easily see the S waves, they are traveling only through a solid. They are not going inside the core. So the S waves, they travel, S stands for solid, so they travel through solids only. They cannot pass through the liquid outer core, and S waves are transverse and they're slower than the other waves. Whereas if you see these blue waves, they are going inside as well. These are known as the P waves. So P waves are longitudinal. They are faster than the other waves. They can travel through solid and liquid, and they can pass through liquid and the outer zone. And you can see this area, which is between the 2 blue waves. There you find no S wave. You only see the P wave. So these are known as the shadow zones. So shadow zones are the places where no P and the S waves are detected. So S shadow zone is where no S wave is there, and P shadow zone is where no P waves are detected. So you can easily see we have drawn the crust, core, and the mantle. The S waves are just at the surfaces. They are not crossing. They are not into the solids and the liquid, whereas P waves are traveling inside. So you should know what is the difference between P wave and S wave, and you should be able to label this on the Earth diagram. Where are the P waves? So they can ask you to draw the directions of the P and the S waves. So you need to be careful that S waves are not traveling through liquids. They are just traveling through solids only, so they'll be at the outer surface only. And the P waves will travel inside the cores as well. Okay, now what information does the seismic waves gives you? It gives us that there's a liquid outer core under the mantle, because you have the shadow zones that are detected as P waves refract twice, once while entering the core from the mantle and leaving the core from the mantle. Since the refraction is further away, forming the shadow zone, it suggests there's a liquid outer core under the mantle, and we have a solid inner core, as the weak P waves in the shadow zone caused by the refraction of P wave while crossing the boundary between the outer core and the inner core. The P and the S wave travel through the mantle, changing direction and depth. P waves refract at the boundaries between mantle and outer core. The S waves being transferred do not travel through liquid outer core. The long L waves travels the slowest. They happen only in the earth crust, and they cause violet movements. Okay, so I hope the seismic wave is clear to you, and what observation they give us on the surface of the earth, structure of the earth, that should be clear to you. Now let's come to a very important topic called electromagnetic spectrum. Now, what is electromagnetic spectrum? It is a spectrum with all the electromagnetic waves arranged in the order of increasing wavelength and frequency. Now, electromagnetic waves are electrical and magnetic disturbances that transfer energy from one point to another, and all electromagnetic waves, they travel with the speed of light, which is 3 times 10 power 8 meters per second, and the frequencies and the wavelength can be given by the formula V equals F times lambda. Now, it starts with the radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays. Now, to remember, radio waves, they are traveling a greater distance. You can see the radio station is in one city. Even you can hear the radios from one country to another. So radio waves have the highest wavelength. So from radio to gamma, the wavelength will be decreasing, and the wavelength and frequency have an inverse relationship. So as from radio to gamma, the wavelength is decreasing, the frequency is increasing. Now, what kind of a question they can ask you in the exam? They can ask you to write these in order. They can ask you which one is having a shorter wavelength or which one is having a higher frequency. So you should know, remember all these waves along with in what order they are. So remember the wavelength order, and reverse will be the frequency order. Okay, now you have different mnemonics to remember these electromagnetic spectrum. You can say, read my instruction visible under X-ray glasses. Rich men in Vegas use expensive girls, or rabbit mates in very ultra-expensive gardens. You can use any of the mnemonics which you find comfortable and easy to remember, where R will be the radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays. And remember, as you go from radio to gamma, the wavelength will be decreasing and frequency will be increasing. Okay, so that's an easy way to remember, and make sure you remember that. It is very, very important. Now you should know for each of the wave, what is the source, their properties, their disadvantages and advantages. So for gamma rays, they are produced when the radioactive substance emitted the nuclear radiations. They have the lowest wavelength, they have the highest frequency, and they travel with the speed of light. For the use, they are used to disinfect food and surgical equipment. They're used to kill cancer cells. In gamma treatment, the cobalt-60 is used to direct the gamma radiation to the cancer cell and kill it without affecting the surrounding tissues. The disadvantages of gamma rays is gamma rays are highly ionizing. Exposure to low dose of gamma rays can cause gene mutation, DNA damage, and even cancer. And exposure to high dose of gamma radiation can cause a killing of the cell. Okay, so remember the uses, the properties, and the harmful effects as well. Same thing goes for X-rays. They are produced by stopping high-speed electrons. They are electromagnetic waves which travel with the speed of light. They have wavelength greater than the gamma rays, but smaller than the ultraviolet rays. They have lower frequency than gamma rays, but greater than the ultraviolet rays. And the wavelength is about the diameter of the atom. The uses is the shortest wavelength X-rays are used in X-ray therapy to kill cancer cells without destroying the healthy cells. And the longer wavelength X-rays are used to photograph the internal structure of the body. These disadvantages are X-rays are highly ionizing, exposure to a low dose of gamma rays can cause gene mutation, DNA damage, and even cancer, and exposure to high dose of gamma radiation can cause killing of the cell. Now, how does an X-ray work? So you can see this is an X-ray machine. The X-rays are passed through the body. The X-rays passes to the soft tissues but are absorbed by the bones and the harder tissues. The X-rays that pass through the softer area reach the detector and appears to be black, whereas the rays that are absorbed do not reach the detector and appears light in the image. If any organ containing softer tissues need to be photographed, then patient is given a contrasting medium like barium, which becomes a good absorber of X-rays and help the photography of that organ. The detector contains a charge-coupled device which converts X-rays to light, which then creates electronic signals which are used by the computer to take the digital image. So you need to remember this information that X-ray pass to the softer areas and to be black, whereas they are absorbed by the lighter areas and do not reach the detector and appears to be light in the image. Next is the ultraviolet rays. They are produced from the sun. They are electromagnetic, which travels with the speed of light. They have wavelength greater than X-rays, but smaller than violet light. They have lower frequency than X-rays, but greater than the violet light. They are used as fluorescent markers or fluorescent lamp, which contains a chemical which converts the UV light to a visible light, and they can cause sunburn and suntan. They can lead to skin cancer, and they can even lead to blindness. For the visible light, the sun and the lamp emit the light. It is the only part of the spectrum which we can see. It is made up of 7 colors: violet, indigo, blue, green, yellow, orange, red. When the white light is passed to the prism, it can give the spectrum of the color. The light is used in a camera to take the picture. Light is also used in light microscope. Light helps to see the object. Light waves are used in communication. The disadvantage is that too much exposure to visible light can lead to cancer, blindness, and skin damage. Next is the infrared rays. All the hotter objects like kettle, toaster, radiator emits infrared radiation. There are electromagnetic waves which travel with the speed of light. They have wavelength greater than the visible light but smaller than the microwaves. They have a lower frequency than visible light but greater than the microwaves. They're used in optical fibers for communication. They're used in remote controls. They're used as infrared scanners to detect heat produced by the body and unhealthy tissues. And infrared cameras helps to see objects in dark. The disadvantages is they can cause skin burn and suntan. They can also lead to skin cancer, and they can also lead to blindness. The microwaves are emitted by cosmic microwave background radiation. Sun also emits some microwaves. They are again the electromagnetic wave which travels with the speed of light. They have wavelength greater than the infrared light but smaller than the radio wave. They have a lower frequency than infrared light but greater than the radio wave, and they are found between the radio waves and the infrared rays. The uses are they're used in communication, they're used in satellite TV, they're used in cooking, they're used to carry mobile phone signals. The disadvantages are exposure to microwaves can heat the body tissues, and exposure to high dose of microwave can cause eye damage and even cataract. Now, this question can also be asked in the exam, how microwave is used to heat the food. Now, the water in the food absorb microwaves and become heated and heats the food, preventing the microwave from heating as it has no water. Now, radio waves can be generated by natural sources such as lightning or astronomical phenomenon, or by artificial sources such as broadcast radio towers, cell phones, satellites, and radar. The properties of the radio waves are they are electromagnetic wave which travels with the speed of light. They have the highest wavelength and they have the lowest frequency. The uses is they are used in communication to carry TV, radios, and mobile signals. They're used in wireless connections and Bluetooth connections. The disadvantages is that exposure to radio waves can heat the body tissues, and exposure to high dose of radio waves can cause eye damage and even cataract. Let's come to the last part, which is the lenses. Lenses are used to refract the light and forms the image of an object. They are used in camera, and these are the two shapes of the lenses. One is this, which is like That's a convex or the converging lens, and concave or the diverging lens. Concave lens, you can see it is just thinner in the middle and then it becomes broader at the ends. So convex lens is a converging lens. Concave is a diverging lens. Convex is thicker at the center than at the edges. The concave is thinner at the center than the edges. Convex has a real focus. Concave has a virtual focus. The convex lens converging a parallel beam of rays on refraction through it, and concave lens, it diverges a parallel beam of light on refraction through it. Convex lens is used in microscope as a magnifying glass. Concave lens is used in telescope. Convex lens is used to correct short-sightedness, where concave lens are used to correct long-sightedness. Now, for the concave lens, you need to remember some of the points. A principal focus, or the focus, is the point where the parallel rays meet or appears to meet. And the distance between the center of the lens and the focus is known as a focal length. Now, if this is my lens, this is my focus, this is the double focus. If suppose I place an object at the focus, in between focus and the center, the first beam of light will go to the lens and then it will bend. And the second one will pass straight through the center. Now, we extrapolate these rays backwards, and where they both meet will be an image. So if on a concave lens, if you put the object between the focus and the center, you will get a small image, a virtual upright and smaller than the object between the lens and the focus. Now, these are the certain ray diagrams for the convex lens which you need to remember. When you place the object between the focus and the lens, in this case, one ray will go towards the lens and will refract at the focus. Second will go from the center. You will extrapolate it backwards. You will get a virtual erect and the magnified image. If you put an object at the focus, then where you will get an infinite distance. These rays will never meet. Even you do here or you extrapolate it backwards. If you put an object beyond the 2F, then one ray will go towards the center, refract at the focus, second will go at the center. You will see they will meet at F and 2F at the other side of the lens. So you will get an inverted real and the diminished object. If you put an object between F and 2F, then you will get an image beyond 2F, which will be inverted, real, and enlarged. And if you put an object just at 2F, you will get the inverted image, real, the same size at the 2F. So you should know how to make these ray diagrams and how to write these characteristics of the object. Okay, so I hope this topic is clear to you. And all these key terms you should be able to define now. What are waves? Longitudinal waves, wave speed, time period, transverse wave, the trap, the lens, the focal length, the crest, frequency, amplitude, wavelength, reflection, refraction, opaque, convex lens, translucent, ultrasound, earthquake, transparent, seismology, seismic wave, electromagnetic spectrum, focus and concave lenses. You can pause the video, have a go at these definitions. So waves are oscillations or disturbances that transfer energy from one point to another. Crest is the height of the wave. Transverse wave, the oscillations are perpendicular. Longitudinal wave, the oscillations are parallel. Wave speed is the distance traveled by the wave each second. Time period is the time it takes for one wave to travel. Trap is the depth of the wave. Frequency is the number of waves passing each second, measured in hertz. Amplitude is the maximum displacement of the wave from the mean position. Wavelength is the distance between two consecutive crest or trap. Reflection is the bouncing of light. Refraction is the bending of light. Opaque do not allow light to be transmitted. Translucent allows some light to be transmitted. Transparent allow all the light to be transmitted. Ultrasound has a frequency of the sound greater than 20,000 hertz. Earthquake takes place when the rocks of the tectonic plates in the Earth's crust or the upper mantle move due to the forces inside the Earth. Seismology Seismology is the study of seismic waves. Seismic waves are the shock wave which originate when the forces inside the earth moves the rocks of the tectonic plate. Electromagnetic spectrum is a spectrum where the waves are arranged in the order of increasing frequency of wavelength. Focus is the point where the parallel rays meet or appears to meet. Lenses are used to refract the light and forms the image of an object. Convex lens is a converging lens. Concave lens is a diverging lens. And the focal length is the distance between the focus and the center of the lens. So I hope this topic of waves is clear to you. Now, as always, your next step would be to check the specification and see if you have covered everything and do the exam style questions. The link is mentioned in the description box below on all the questions topic wise on this topic. If you like this video, then do not forget to subscribe to my channel and click the bell icon so that you are notified as soon as I put the new videos. As during the exam time, I put a lot of revision videos. Do not forget to follow me on Instagram at Expert Guidance, where I share key terms, daily revision tips every day. And if you are really keen on doing the GCSE course like in 15 weeks, I have designed a new course, which is a 15 weeks GCSE revision course, which is all free. The link is mentioned in the description box below. You can enroll for this course and you can get all the materials for maths and science to your inbox every week as per the 15 weeks plan. Okay, so I'll see you next in my next video. Till then, happy revising.